Hello everyone, welcome to the Module 2. So before you start watch the video, I would like you to go through the reading guide at first to go through what my expectation for you to understand in this module. And after you quickly review these questions, then you can download the reading material and then watch the video at the same time to go through the lecture with me. Okay, so you can continue the video when you are ready. Alright, let's start the content of the Module 2, which I will show you how to identify and define the problem before we actually do the business analytics. So before diving into data, the very first step in business analytics is to understand the business itself clearly, completely, and from the right perspective. This step is called determining business objectives and is one of the most critical steps in any analytics project. The first task for any data analysis is to thoroughly understand what the business wants to accomplish. Often, business leaders have multiple goals, sometimes even conflicting ones, along with various constraints like time, budget, or resources. So our job is to uncover these key factors right from the beginning, because failing to do so can lead to a classic mistake, which is spending weeks or months producing the right answers to the wrong questions. So there are three outputs of the first task, including background, business objectives, and business success criteria. The first output is detailed description of the business background. This captures what we already know about organization situation, like the industry, the market challenges, opportunities, and internal process. It sets the context for everything that follows. The second output is the formal list of business objectives. These are written in plain business terms to ensure that technical work directly supports the company's strategic goals. Without a clear understanding of what the business wants to achieve, even the best analysis can become irrelevant. Let's look at an example. In today's highly competitive market, customer retention is a top priority, especially for the industry like banking. So a bank might set its primary business objective as improve customer retention by predicting which customers are likely to leave for a competitor. So by analyzing historical data and customer behavior, the bank hopes to proactively engage at-risk customers, offering personalized promotions or enhancing services to prevent churn. So in addition to this primary goal, the business might also ask supporting questions like how do different customer channels like mobile apps, branch visits, or ATM usage affect churn risk? And would changing operational policies like lowering ATM fees help retain high-value customers? Or are certain customers segments based on the age, location, or account types more likely to leave? So answering these questions help business design a more effective and data-driven customer retention strategy. And then the third output is define the business success criteria. This is how we measure whether the project actually delivers value. It might be something specific and measurable, like reduce customer churn rate from 15% to below 10% within 6 months by using a predictive model to identify at-risk customers and applying targeted retention strategies. So you can tell that the clear success criteria make sure everyone from the data team to the business leaders knows what success looks like. So remember, This step isn't about jumping into the data. It's about stepping back to ask, what does the business really need? A clear business background, well-defined objectives, and a measurable success criteria lay the foundation for a successful analytics project. To truly understand how to define business objectives in an analytics project, let's walk through 4 practical cases from different industries. The first case is a large retail chain wants to boost customer loyalty. Their goal is to encourage customers to buy more and buy more often. So, the business objectives are to increase the repurchase rate of existing customers. And as a result, the business success criteria, we can see that as to grow repurchase rate by 5% next quarter. And then the second business objective could be optimize the membership program to make it more attractive. And in this case, the successful criteria could be increase membership participation by 10%. And then we can also have a business objective to boost sales through personalized recommendation and using improving the conversion rate of personalized offers as the success criteria. And then we can go to the second case, which is a major bank that is struggling with high-value customers leaving for competitors. So their mission is to reduce the churn and keep their most valuable clients. Firstly, what they have to do is they have to identify why these high-value customers are leaving. After identifying the reason, and then the success criteria could be cut the churn rate by 15% within 1 year. And then they can offer better financial products and services to boost cross-selling rates among those high-value customers. And at last, they also want to improve customer satisfaction and take action quickly. And so in this case, their success criteria could be raise certification scores by 2 points. And now you have the third case, which is the e-commerce platform try to organize the advertisement spend. So their business objective, the first of all, is to improve the conversion rate and sales from the advertisement. So straightforward, their success criteria could be increase the conversion rate by 15% in the next quarter, right? And then there's another way to increase the conversion rate, which is to lower their cost per click and the cost per acquisition. So in this case, the successful rate criteria is to decrease the cost by 20%. And then they also want to improve the conversion rate of personalized recommendation. So their success criteria could be increased participation in the membership program by 10%. And then we have the last case, which is a large retail company wants to optimize its inventory management system to reduce holding cost and avoid stockouts. Because the company has multiple warehouses and distribution centers, and then they're facing challenges in inventory management, including excess inventory, stockout, and supply chain delays. So in order to improve all those business process, they want to firstly reduce the inventory holding cost, right? And then so their success criteria could be set a number or the percentage, which is to reduce inventory holding cost by 15% in the next fiscal year. And the same thing, they also want to avoid stock out and ensure a timely supply of the products. So so the successful criteria could be lower the stock out rate to below 2%. And at the last, they want to think more further, like they want to optimize the inventory replenishment strategies to improve supply chain efficiency. And in this case, the success criteria is to improve overall supply chain efficiency and reduce average replenishment time. So now we can clearly see that the business objectives are always the high-level goals. They describe what the business really wants to achieve, often in broad, strategic terms. But on the other hand, the success criteria are measurable. They define how you will know if you actually achieved the objective, often use specific numbers, percentage, or the deadlines. In a preview step, we define the business objective, what the company wants to achieve from a strategic perspective, right? And now it's time to translate that into a technical goal that guides the analytics process. And this step is called determining goals. So while the business objectives speak the language of the business, the determining goal converts that into the language of data, technical, measurable, and actionable. So let's look at an example. So the business objective might be increase catalog sales to existing customer, right? So this is a high-level goal, focusing on improving revenue by encouraging repeat purchase. And then the corresponding determining goal could be predict how many product a customer will purchase based on their purchase history, demographic like age and income, and the price of the item. So this technical goal supports the business objective by producing predictive insight that help understand and influence customers' behavior. So there are three key ways the business objective and determining goals connect. So the first one is the linking goals. So for example, to increase the catalog sales, the company needs to understand patterns in customers' behavior. And then the determining helps by using historical data to predict future purchases and to enabling smarter business decisions. And then the second one is actionable insights. Because the predictive models can identify which customer segments are likely to buy more, like based on the factors like demographic, the purchase frequency, and pricing sensitivity. And this result allows the business to create a targeted marketing, adjust the pricing, or offer personalized promotions that drive additional sales. The third one is iterative process. The determining isn't a one-time event. It is an iterative process. So you build models, apply them in the business, monitor the result, and then refine the models over time. Each cycle helps improve both the technique models and then the business strategies they support. So the key output from this step is a clearly defined determining goals. It describes the specific deliveries such as the predictive models or the classification rules or the customer segment. So these are the result models of the data analytics project. And don't worry, we will learn all of this through the whole semester. So these outputs directly support business decisions and actions. So in summary, the step is about bridging the gap between the business needs and the data-driven solutions. A well-defined determining goal ensures the analytic team know exactly what to build, and that their work directly supports the company's strategy priorities. So now we understand what a determining goal is and how to connect to the business objective. So to make it clear, let's go back to the 4 cases we discussed earlier. And for each case, we will take the business objective we already defined and then show how they translate into the clear and technical data mining goals. This will help you to see exactly how business questions are transformed into data-driven tasks that guide the entire analytics process. Let's start with the retailer who wants to boost customer loyalty. All right, if you remember the case one. And there are three clearly business goals in this case. The first one is to increase repurchase rate by 5%, increase the membership program participations by 10%, and also to improve the conversion rate of personalized product recommendations. So now, to reach these goals, they need to understand how customers behave. And that's where data mining comes in. First, we can look at the purchase history, frequency, and the customer's demographic to predict which customers are most likely to buy again. So that way, they can send the right offers to the right people. And second, they need to figure out what makes people join the membership program. Is it discounts, convenience, previous purchases? Data mining can review patterns that helps to improve the program and its marketing, so that to optimize the membership program using customer behavior and preference data. And finally, to boost sales through recommendations, they need to build models that suggest the right product, and using techniques like collaborative filtering and customer segmentation. Next, let's look at a bank. They've noticed that high-value customers are leaving for competitors, and that's a big problem. So here are their business goals. They try to understand why high-value customers are leaving and offer better products to retain them, and then monitor satisfaction and act early. So how can data mining help? First, by analyzing customers' activity, service interactions, and complaints, the bank can identify early warning signs of the trend, like fewer logins or increased complaints. And next, they can use predictive models to score customers based on how likely they are to leave. This lets the bank focus retention efforts where it matters most. And lastly, to actually retain these customers, the bank can segment them based on behavior, product usage, and financial profile. With this segment, they can offer personalized services, improving satisfaction and boosting cross-sales. And now we can look at an e-commerce platform that wants better results from their advertisements. So their business goals are to increase advertisements conversion rate by 15%, right? So by reaching this target, they can analyze past campaign data. They can also see which advertisement channels, audience, and creatives deliver the best result, and which don't. And their second business objective is to reduce advertisement cost by 20%. So they can use machine learning models to predict how new campaigns will perform, like what CPCs and CPAs to expect, and where to allocate their budget. And finally, they want to improve the conversion rate of advertisement. So they can use machine learning models to predict which advertisement strategies are most likely to improve their conversion rates. And finally, in our last case, a retail company is struggling with inventory. And their business goal is to cut inventory holding costs by 15%. And so they need to forecast demand at the store and warehouse level. So they can analyze sales history, seasonality, and even weather to match the supply with demand. And they also want to reduce the stock out to below 2%. And in this case, they can use predictive models to determine the best times and amounts to reorder, avoiding both overstocking and running out of the items. And their last objective is to improve supply chain efficiency. And what they can do is they can analyze supply chain data to support where delays happen. Maybe certain roads or suppliers are causing the issue. So this insight help improve process and keep shelves stocked. So there you have it, for a real-world example showing how business objectives lead directly to data mining goals. So from predicting customers' behavior to improving supply chains, data helps organizations make smarter, faster, and more impactful decisions. Now, let's review the question 3 from week 1 and categorize the data mining goals mentioned before to different analyze types. As we described in the week 1, analytics is generally thought to comprise 3 broad categories of techniques: descriptive, predictive, and prescriptive analytics. Descriptive analytics doesn't try to predict the future or recommend actions. Instead, it helps us to understand past data so we can make smarter decisions going forward. Let's walk through the 5 most common techniques used in descriptive analytics, each with a real-world example. So think about this, like asking your database a question. For instance, hey, show me how many products we sold last month. So a data query pulls out the specific information, fast and focused. It is great for checking on a particular slice of your historical data. Reports and descriptive statistics give you the big picture. Report provide a structured summarized of the data, while descriptive statistics such as a mean, median, mode, standard deviation, and range quantify basic features of the data. They can offer a clear and concise overview of the data. For example, here is a sales report summarizing the sales of different soft drinks along with statistical information across various audit periods. Data visualization, including charts, graphs, maps, and dashboards to make data easier to understand. So here is a line chart showing the sales trend for last years in 2 different regions. We can easily see the trend of how the sales goes through the whole year without just checking the numbers. In addition, data mining looks through massive datasets to find patterns or trends, things we might never notice on our own. And some simple spreadsheet tools allow users to test the different scenarios by adjusting inputs and observing outcomes. Now let's talk about the predictive analytics, one of the most powerful tools business used to look into the future. Predictive analytics use models built on the past data to forecast what is likely to happen next, or to understand how one factor affects another. Imagine a company launching a new product. They might use customer service and historical purchase behavior to predict something like the future market share. First up, we have a linear regression. So it's perfect when you want to predict a continuing number, like the exact percentage of the market share of your new product might capture. So you can use customer average past spending and product category popularity as input to predict the interest scores as the outcome. And then we also have a logistic regression, which is all about yes or no questions. So we can predict whether the customers are interested in the product, so the interested as 1 and not interested as 0, based on the demographic and purchase trends. So now we can see that the data used in linear regression and logical regression are the same. So what exactly is the difference between a linear and logistic regression? Linear gives you a number, like predicting a score from 0 to 1. It could be 0.3, 0.5, or 0.75. Logistic gives you a category, like interested or not interested. So the key lies in the nature of the prediction, numerical versus categorical. We will talk about it in the semester later, so don't worry about it right now. And finally, there is another predictive analytics, which is called time series analysis. These ones are about tracking and forecasting trends over time. Let's say you want to predict monthly market share for your new skincare line. By analyzing the past performance, seasonal patterns, and similar product launches, time series models can help forecast the next 12 months, helping you plan production, marketing, and more. Prescriptive analytics, on the other way, differs from descriptive and predictive in that prescriptive analytics indicate a course of action to take. That is, the output of a prescriptive model is a decision. Predictive models provide a forecast or prediction, but do not provide a decision. However, a forecast or prediction, when combined with a rule, become a prescriptive model. For example, optimization model finds the best way to allocate resources like the budget or inventory to maximize profit or minimize the cost. A company might use an optimization model to decide how to split its marketing budget across different products to boost profits, all while staying within the cost limits. So in this case, the allocation of the budget is the decision, and they use the data from the past, and maybe they use the result from descriptive analytics or predictive analytics. But since there is a decision to allocate the different budget, this analytics is belong to prescriptive analytics. And in another example, we also have the recommendation systems, personalized action plans based on the customer behavior and demographic. Unlike simple predictions, this system suggests concrete strategies, like when outsourcing production becomes cheaper than manufacturing in-house. It can help managers make smarter choices. And finally, we have another prescriptive analytics, which is called scenario analytics. It lets business simulate what-if scenarios. It can use to test different strategies before deciding. Imagine comparing revenue if the weather is sunny, raining, or partly cloudy. This helps companies weigh risks and opportunities and pick the strategy that maximizes expected success. To sum up, prescriptive analytics empower you to move from insight to action, making smarter, data-driven decisions that drive real results. Now let's go back to the case study we've done before and then try to find out what type of analytics each data mining goals belong to. So in the first case, we're looking at how a large retail chain uses data mining and analytics to boost customer loyalty, right? So their strategy focuses on three main business goals: improving repurchase rates, increasing membership participation, and boosting conversions through personalized recommendations. Let's break it down by each goal and the type of analytics used to support it. First, the company wants to increase the repurchase rate. To do that, they analyze purchase history, buying frequency, and demographic data to predict which customers are most likely to come back and shop again. This is a classic case of predictive analytics. We are using past data to estimate future behavior. So with this insight, the company can send targeted offers or reminders to the right customers, helping them hit that 5% repurchase growth goal. Now let's look at the second goal, optimizing the membership program. Here, the company digs into customers' behavior and performance data to figure out what really drives people to join and stay in the membership program. But they're not just exploring data, they are using it to make decisions on how to redesign and optimize the program. That makes this prescriptive analytics because the result is a course of action. And finally, boosting sales through personalized recommendations. To achieve this, the company builds recommendation models using techniques like collaborative filtering and customer segmentation. These models don't just forecast performance, they suggest specific products for each customer. That's another form of prescriptive analytics because the model directly tells the business what action to do, like suggest products to increase conversions. As a result, the first determining goal is a predictive analytics, and the second one and third ones, they are prescriptive analytics. Now, in the second case, we focus on a bank aiming to reduce churn, especially among high-value customers who've recently started switching to competitors. To tackle this challenge, the bank has outlined 3 clear objectives, including reduce the churn rate of high-value customers by 15% within a year, boost cross-selling rates among high-value customers, increase customer satisfaction scores by 2%. The bank's first move is to analyze transaction behaviors, customer service records, and complaint logs to uncover the behavior patterns that often come before a customer leaves. This type of analysis is called descriptive analytics. It answers the question, what happened and why? Once the bank understands why customers leave, the next step is to predict who is likely to leave next. This is where predictive analytics comes in. By using models like logistic regression or machine learning classifiers, the bank can assign a churn probability score to flag each high-value customers. That way, they can take action early, reaching out before a value client walks away. But identifying risk is only part of the solution. The bank also needs to decide what to do for each type of customer. Using clustering techniques, the bank segments customers by risk level and product usage. This is a combination of descriptive and prescriptive analytics. Descriptive because it shows us what different customer groups looks like. Prescriptive because it helps decide what personalized offer or strategy to use for each segment. Now let's check the case 3. In today's digital marketplace, an advertisement budget must be spent wisely. This e-commerce platform is tackling that challenge head-on by using analytics to improve advertisement performance and maximize return on investment. The first step, understanding what's worked in the past. The company dives into historical advertisement data, impressions, clicks, audience types, creative formats to find the patterns. This is an example of descriptive analytics. It answers which advertisement, channels, and audience performed the best before. By summarizing this data, marketers can focus future efforts where they're likely to get the best results. But understanding the past is only part of the story. To improve efficiency, The platform also uses predictive analytics, building machine learning models to forecast campaign performance. These models estimate key outcomes like cost per click, cost per acquisition, and conversion rate based on the campaign setup. That way, marketing teams can avoid overspending before the first advertisement even runs. And to take things a step further, the company turns to prescriptive analytics. How? By using personalized recommendation models. This system don't just guess what performance might like. They tell the platform what to show each user. Whether it's collaborative filtering or market basket analysis, these tools guide real-time decisions to show the right product to the right person, increasing both conversion and membership participation. At last, managing inventory is just about counting boxes. It's about making smart and data-driven decisions that save money and keep customer happy. In this case, a large retail company is facing two major challenges: high inventory holding cost and frequent stockouts. To solve them, they turn to analytics, and here is how it works. First, the company needs to forecast product demand. They analyze historical sales, seasonal trends, and external factors like holidays or weather. This process begins with descriptive analytics, like summarizing past patterns, but it doesn't stop there. By applying predictive analytics, the company forecasts how much stocks will be needed at each warehouse in the coming weeks. This dual approach helps strike the perfect balance, not too much, not too little. Next, it's time to figure out when to reorder and how to restock. This is where predictive models come in play. These models calculate optimal reorder points and quantities, ensuring that products are replenishment just in time, without overstocking or running out. Thus, predictive analytics in action, anticipating future needs and responding before problems happen. But what about supply chain delays? To address this, the company analyzed shipment data, suppliers' performance, and delivery time. Descriptive analytics highlight bottlenecks, such as slow suppliers or inefficient routes. Prescriptive analytics takes it further, recommending actions like switching vendors, rerouting shipments, or optimizing warehouse workflows. This means the company isn't just spotting problems, it's solving them. So how can you tell whether a data mining goal is descriptive, predictive, or descriptive? Let's breaking it down, and all you need to look at are the words and the purpose of the goal. If the goal say things like analyze, identify, or summarize, you are looking at descriptive analytics. Why? Because it's focused on what has already happened, uncovering patterns in the past data. Example, analyzing sales history to identify customer purchase patterns. That's descriptive. It tells you what happened and why it matters. Now, if your goal uses words like the predict, forecast, or estimate, that's a sign of predictive analytics. This type answers what is likely to happen in the future. The example could be forecast next quarter's sales using past trend. You're using a model to look ahead. That's predictive. And if a goal is to recommend, optimize, or simulate, you are using prescriptive analytics, the most action-oriented kind. Prescriptive analytics tells you what should we do. It uses predictions and constraints to recommend the best course of action. For example, you can see optimize advertisement budget across channels to maximize ROI. Here, the goal is to act on the data, not just observe or predict. So in many cases, goal may combine these types, like using descriptive analytics to understand a problem and then applying prescriptive techniques to suggest solutions. By paying attention to these key terms and intentions, one can accurately classify the analytical approach that have been used. Now, we learn how to transform and conclude data mining goals based on business objectives and categorize the data mining goals into different analytical types. But in prescriptive analytics, since it is to provide recommendations on actions, there is a further step for us to deal with the data mining goals, which is called problem formulation. It is the process of converting a real-world business problem into a mathematical framework that we can analyze and solve. It is a core step in prescriptive analytics, and it forms the foundation for making optimal decisions. The problem formulation isn't just about plugging numbers into formulas. It starts with understanding the business context, knowing the objectives, and identifying all the constraints that shape the decision. The first two steps in this process are to understand the problem thoroughly and clearly define a business objective. We've already covered these two steps in section 1.1 and 1.2. Next, we identify the constraints, which are the rules or limits that must be respected. These might come from budget, resources, regulation, or operational boundaries. For example, we want to have the total cost which is less than the budget, or we want the quantity of the products in the inventory more than a specific number. And then next, we will define the decision variables, which is the things we can control. In the marketing, a decision variable could be the budget for each advertisement channel. And in the inventory, it could be the reorder quantities. These variables turn the business into the math terms, make them be able to be analyzed. So, once the variables are set, we write the objective function using the variable. So this describes what we want to achieve, usually maximizing profit or minimizing the cost. For example, we want to maximize the ROI, the return of the investment, which we can use the total return to minus the three different advertisement spend as the investment across the different channels. And then we can also express the constraints using decision variables. Like if we have x1, x2, and x3 are advertisement spends across different channels, then we can say x1 plus x2 plus 3, this should be less than or equal to our budget, right? So this ensures the solution realistic within our budget or resource limit. So together, there are 6 steps. Understand the problem, define the objective, identifying constraints, set decision variables, write the objective function, express constraint in math terms. So these 6 steps form the core of a good prescriptive model. Now to better understand how we formulate a problem in prescriptive analytics, let's walk through a real-world case study, which is a company called PAR. It's a small golf equipment manufacturer entering the golf bag market. So PAR Inc. is preparing to launch a new product line of medium and high-priced golf bags. Their distributors has already agreed to purchase everything they produced in the next 3 months. They gave PAR a clear goal. to maximize profit under limited production resources. So the company plans to produce two models, a standard bag and a deluxe bag. Each model requires time in 4 departments: cutting and dyeing, sewing, finishing, and inspection and packaging. So we can tell from this table that this table shows the number of hours required in each department to produce one standard or deluxe golf bag. For example, to produce one standard bag, it takes 0.7 hours in cutting and dyeing, and then 1 hour for produce one deluxe bag. And then a standard bag requires 0.5 hours in sewing, and a deluxe bag requires 5/6 of an hour in sewing. And a standard bag takes 1 hour in finishing, whereas a deluxe bag takes 2/3 of an hour in finishing. And at last, a standard bag needs 0.1 hour for inspection and packaging, and the deluxe bags need 0.25 hours in inspection and packaging. So this is the background understanding of the whole PAR company and then their situation right now. And now let's check about constraints. PAR has limited labor hours available across departments over the next 3 months. Their workers are only be able to work 630 hours for cutting and dyeing, 600 hours for sewing, 708 hours for finishing, and then 135 hours for inspection and packaging, totally together. But on the other way, in terms of profit, based on the labors, based on all the cost, every standard bags can have $10 as a profit, and then every deluxe bags can have $9 as a profit. So now the question is, how many of each type, either the standard or deluxe bags, should they produce to maximize profit contribution without existing time limits or the other constraints? And then we can go through the 6 steps of the problem formulation. Step 1, understand the problem. So they understand that the problem for them is they have to decide how many standard and deluxe bags to produce. And for what kind of objective? So their goal is to maximize the profit. Right, so these are problems and objectives. The problem is how many standard bags and deluxe bags they have to produce. So this is the action. They need some recommendations on the numbers, like how many standard bags and how many deluxe bags. And then what's about the objective is what they want. So they want to maximize their profit. So this is very clearly first 2 steps. And then we have to describe the constraints. So the time limits for each department became the resource constraints. Right? And then we have described that before for each of the department. And we also have like 2 implicit constraints. The first one is called non-negativity. That means we cannot produce a negative number of bags. And then the integral constraints is like we cannot produce fractional bags. It's like we cannot produce half bag. These are the normal constraints that they were not mentioned or described in the business background, but we should understand it as a common way, okay? And now we can define the decision variables now. So a decision variable is in any mathematical model is a controllable input that the decision maker can change or adjust, right? So in the context of the PAR company, the number of standard bags to produce and the number of deluxe bags to produce are not fixed. They are the choice the company must make based on the resources availability and the profit emergence. So as a result, the number of the standard bags and the deluxe bags are considered as decision variables because they represent the key quantities that the company must determine in order to achieve the goal, which is maximizing the profit. So we can set S equals to the number of the standard bags and D equals to the number of deluxe bag. In optimization terminology, S and D are referred as the decision variables. So the step 5, write the objective in terms of the decision variables. So we've already set up the decision variables, which is S and D, right? So now we have to understand how we're using the S and D to represent the objective. The par's profit contribution comes from two sources, the standard bags and the deluxe bags, right? So if par makes $10 for every standard bags, and then the company will make $10 multiplied by S if S standard bags are produced. Also, if par makes $9 for every deluxe bags, the company will make $9 multiplied by D if D deluxe bags are produced. So we have total profit contribution equals to 10S plus 9D. And the objective will be to maximize this 10S plus 9D. So this is called objective function. And step 6, we have to write the constraints in terms of decision variables. So the par's production is constrained by a limited number of the hours available in each department, right? So for cutting and dyeing, each standard bags require 7/10 hours, and each deluxe bags require 1 hour. So the total production time will be 7/10 multiplied by S plus 1 multiplied by D. Also, since the constraint of the cutting and dyeing is 630 hours, we can write this constraint as 7/10 multiplied by S plus 1 multiplied by D less equals to 630. And this is how we're using the decision variable to express one department constraints. And then we can do the same thing for each of the department. Like for the sewing, the constraint would be half hour multiplied by S plus 5/6 multiplied by D less equals to 600. And then for the finishing, it should be 1 multiplied by S plus 2/3 multiplied by D less than 708. And it allows for the inspection and the packaging. The constraint could be written as 1/10 multiplied by S plus 1/4 multiplied by D less equals to 135. And thus we can write the 6 steps like this. And then don't forget about the additional constraints that S and D, they should be both more than 0, and S and D, they should both belongs to the integers. And by completing these 6 steps, we've built a clearly optimization models for the par. One that balances limited labor resources against the profit contributions from the two product types. And this model allows the decision makers to calculate the best production mix to maximize the profit. This is a perfect example of how prescriptive analytics turn business strategy into the actionable decision.